Welcome to 3.6 class. We are almost done with the shortcut of the taking derivatives. So today we are going to review a little bit more about the chain rule and then inverse functions. So I want you to review together with me what was a chain rule. Chain rule was when we had a composite function, we have to take a derivative of outside function first, and then we multiply inside function of the derivative. So if it's a two composite function, you are going to multiply two of them. If it's three, there will be three functions you will multiply. Okay, now let's recall, do you remember exponential function derivative? That will be a to the x is going to be natural log of a times itself. Don't forget, you're gonna get yourself. And then today we are going to learn about what is the derivative of a natural log. So natural log is 1 over x. Don't forget this is a natural log. And now I want you to also think about derivative of the trig function. If you want to recall, you can pause it and write it down, or you can do it together with me. So derivative of a sine is a cosine x. Cosine is negative sine x. Tangent is going to be secant square x or 1 over cosine square x. I want you to know both ways. It comes both common. And then this is a tricky one. When we have a cosecant, I actually double check and then our formula all correct. So you must have a cosecant x. And then remember, you're going to have a cotangent here. So just a CC, and then you are going to be negative. Then if you follow this one, try to apply a little bit logically. So here's going to be secant. So you're having secant x times a tangent x. Do you think you can remember that? It follows. Okay, this one has a cotangent, then this one has a tangent. And cotangent derivative is negative cosecant square x. So that's the derivative of cotangent. So try to recall because for the integral in the future. So today I'm going to show you new derivative of those three inverse trig function. Inverse trig function. So what will be the derivative of inverse trig function? Here arc sine is going to be 1 over, I remember as a square root of 1 minus x squared. Then our cosine x is negative 1 over square root of 1 minus x squared. And then our tangent x is 1 over 1 plus x squared. I'm gonna check if mine is correct. That's my memory of what I remember. So I want you to check and then also memorize it with me, okay? Okay, so now let's look at appetizer. When you look at A, can you guys see how many circles we are going to have? Could you try all 6 of them, okay? If you want to pause it, please do. It's important how many functions are in here. Let me see. Okay, then after this one, let's try to take a derivative. So now you say chain rule, chain rule, chain rule. How are we gonna take a derivative? Taking derivative of 2 to the t first. That will be 2 ln and 2 times itself. And then I need to take a derivative of inside function. That will be 3. So my total answer will be times 2 to the 3x. That's my final answer. Continue. So next one, when you see here, we saw that natural log has a rule 1 over and whatever inside. But as you see, we have to take a derivative of inside as well. So square root of x minus 1, you may notice we done a lot of times. It's going to look like this way. So if you organize it, you can write it 1 over 2. By distributing, you can do 2x minus 2 root x. Yeah, I think that looks nice, right? And then last one, this one is going to be a little bit more tricky. So outside I have a square root of t function. So let's take a derivative. Then that's going to be, let's see if I have enough room. 1 over copy down what you have. 3 plus natural log of y minus 1 times, oh, that's going to 2, right? 1 over 2 times, now we are going to take a derivative of that one. That's going to be 1 over 3 goes away. Natural log will be 1 over y minus 1. Are you following? Okay, I did a second circle, which if you say function 3 plus natural log of t, that's what you can think. Then take a derivative, you get 1 over t, which is 1 over y minus 1. And then now you have to take a derivative mostly inside y minus 1, which will be 1. So I need to take it as a 1 here. Oh, okay. So now I actually have to change this one to f over y. I think there's a little mistake because that y is not same as that one input as y. And then now I want to try in class activity 3 of them and compare with me. So let's compare the class activities. When you look at the first one, if you see these two chain rule, outside function and inside function. So I organized it. Second one, as you saw, did you notice that I have to have a product rule and chain rule here? So if you look at, I took the product rule, so take a derivative and then leave it, plus leave it, and then take a derivative. So careful about that, and then I break it down the procedure here. So after I simplify, that's what I got. Keep practice with me. And then last one, just I want you to recognize that one because this one will pop up in next semester, like an integral 1 over square root of 1 minus t squared, and it's gonna be dt. It's hard to recall because it doesn't look like a trig function, right? So I want you to recall that this is related to arc sine. So 1 over square root of 1 minus t squared. And this will be very important fact in calculus 2. So I want you to recognize this one. So let's continue our main dish, how we take the derivative of the trig inverse function. So do you remember derivative of arc sine x is 1 over square root of 1 minus t squared, and arc cosine x is negative and same one, and arc tangent x derivative is 1 over 1 plus x squared. This is going to be also very important later on when you take the integral. You have to be able to see it. It's a little bit harder to recognize, so I want you to keep practice. So let's look at next one. Let's circle it again. Do you see there how many composite functions? How many composite functions? Okay, then let's try to take a derivative one by one. What was the derivative of arc sine? That is 1 over square root of 1 minus input square, right? And then, so I'm done with outside one. Now we have to take a derivative of inside function, which is going to be 3t squared. So if we organize, that will be 3t squared over square root of 1 minus t to the 6. That's it. Okay, let's look at next one. So again, outside of the derivative, arc cosine derivative is going to be 1 over square root of 1 minus something input square, which is a tangent theta square, and then minus. Okay, so I did outside, and now we need to do inside. Do you remember what was the derivative inside? So tangent derivative was secant square theta, or 1 over cosine. So I'm going to write it as a secant square theta. Okay, I want to see anything if I recognize. So do you guys see that outside function derivative, inside function derivative? Feel like something is going to happen. So that is going to be negative 1 square root of 1 minus tangent square theta. Anybody remember the identity? I'm going to look at the identity here. I see that this one can be rewritten. Top is a secant square. So there was a one identity. I see the tangent square theta plus 1 is equal to secant square theta. I don't see anything I can use here. Right? I wish that was the other way around. And then top one, I could write it as this way. but that's about it. I don't think I can write anything better. So you can leave your answer this way. Yeah. Because I thought that we could use identity, but identity doesn't really fit in here. That I wish that that was minus. You think so too, right? Another way that you could write it is just a top instead of secant, you can write tangent square that minus plus 1 over this one, just having same tangent. But this is it. Okay, pause it. Now I want to try in class activities quickly. So compare the answer with me. So derivatives are like this. When you do it with me, it always looks easy, and when you do it by yourself, it seems really be hard. So I want to keep trying, and of course you can do it with me during the office hour. So please and visit. For me, I did more than 1,000 of them, I remember, seriously. So that's why I got it a lot faster. So keep playing like a video game. You can do it. Okay, so in my main dish, we are going to now study about derivative of general inverse function. That means if I have my original function, what would be the slope of the inverse function? So let's look at our example here first. 3x plus 1, I know how to graph it. And that's going to be this way. And then let's find our slope here. So my original function, the slope is 3. Now let's find our inverse function. In order to find inverse function, we're switching x and y. So x is equal to 3y minus 1 and plus 1. And then solve for y. So it's going to be 3y is equal to x minus 1. And divide by 3, so y is equal to 1/3 x minus 1/3. So I'm going to graph my inverse function. Then negative 1/3 as y-intercept, and then slope is going to be 1/3. So if it goes 1 over 3 like that. So if you connect, it looks like this way. And how do I know that this is going to look this way? Because I know that that point is inverse as a 0, 1, pass through 1, 0. I know 1, 4 has to be 4, 1. Because the inverse switching x and y. So now I have my red color, which is my inverse. What is the slope? What is the slope? Do you see that slope of this will be not perpendicular slope. Slope of the inverse. Slope of the inverse is 1/3. So do you see that? It's just reciprocal. So if I have, let's talk about with given example here. Using first one, what is the f of 1 here? Then f of 1 is going to be 4. Then what about inverse of 1? What does that mean? That means now we have to rewrite this one. Inverse function is this one, so you can plug in 1 here. Then that's going to be 0, right? If you plug in 1/3 minus 1/3 is 0. And what does this mean now? This means derivative at 1, slope at 1 is 3. Then can you see what that means? What is the inverse function? Derivative. Do you see the notation? Then it has to be reciprocal, so it becomes 1/3. It becomes 1/3. So if you want to have derivative of your inverse function is 1 over your original function, their derivative. Makes sense to you? If it's a 3, it's going to be 1 over 3. So now I want you to try this one. Y is equal to x squared. You can do it together with me. So if I graph y is equal to x squared, I have my graph shaped this way. Then now what is going to be the inverse function? Y is equal to x squared. Inverse function will be x is equal to y squared. Therefore y is equal to plus my square root of x. I'm gonna have my function upper part and then down part. But in order to be inverse, we only use positive side and positive side. So now I have my original and inverse function. Let's try to answer one by one. What's f over 1? What's f over 1? When you look at next one, that's going to be 1. Then what's the inverse of 1? Then I'm talking about my inverse function. plug in 1 will be square root of 1 is 1 again. Okay. Now, what does this mean? What does this mean? What is the slope at 1, right? Slope at 1. Then we can take a derivative. We take a derivative that becomes derivative function 2x. So slope at 1 is 2. Because I plug in 1, that's going to be 2. Then what does that mean? What is the slope of inverse function? So I had a slope 2 here. Then what is the slope of your red color function has to be? Can you guess? That has to be 1 over 2. So that is going to be inverse function relationship. Just keep think about it logically. And now I want you to actually find the slope at x is equal to 2. What would that be? Why is the slope at 2, class? Anybody see it? If I plug in, do you see that that slope has to be 4? Then what is the slope of the inverse function? That is going to be 1 over 4, right? It's going to be 1 over 4. Careful about that. Okay, so that's it. And good news, we have no dessert. Yeah, so just do your best when you do homework. There are 10 questions, and then I will see you next class. Bye.